Hello, algebra students. In today's lesson, 2.3, we're going to be solving inequalities using multiplication or division. So this is actually split into two parts. Part 1 is multiplying or dividing by a positive number, and then part 2 is going to be multiplying or dividing by a negative number. Make sure you pay attention to whether or not it's negative because there is a trick you have to do when it's negative. So let's start with the easier one. Core concept, solving inequalities, multiplying and dividing by a positive number. And let's look at some examples. So solve each inequality, graph the solutions. When we have x divided by 8 is greater than negative 5, we're going to treat this the same way we would an equation. So to get rid of that divided by 8, we have to use the inverse operation, which is multiplication. So multiply both sides by 8. 8's cancel out. I have x is greater than negative 5 times 8, which is negative 40. If I graph this, I have a circle at negative 40. I do not shade it in because it's not equal to, and x is greater than, so it points to the greater numbers. All right, part B, 36 is greater than or equal to 4b. b is being multiplied by 4. I want to get b by itself, so I divide by 4, inverse operations. 36 divided by 4 is 9. So I have 9 is greater than or equal to b. 4's cancel out. And it's easier to read these if the variable is first, so I can rewrite this as b is less than or equal to 9. So circle at 9, shade it in because it's or equal to, and b is less than, so it points to the lesser numbers. All right, so here's where it gets a little tricky. Solving inequalities, multiplying or dividing by a negative number. I want you to write this in your notebook, highlight it, star it, whatever you want to do. When you multiply or divide by a negative, flip the inequality sign. When you multiply or divide by a negative, flip the inequality sign. What that means is if it's x is greater than, you're going to flip it, so now it's x is less than when you divide by a negative or multiply. All right, so now let's practice this. We have negative 7 times y is less than or equal to negative 35. To get y by itself, I have to divide by negative 7. When I divide by negative 7, I'm going to flip the inequality sign. So it was y is less than or equal to. Now it's y is greater than or equal to. Negative 35 divided by negative 7 is positive 5. So how we're going to graph this? And do our number line, 3, 4, 5, and switch colors. Circle at 5, shade it in because it's or equal to, arrow goes greater. All right, so this can be a little tricky to wrap your head around, but if we plug numbers in, we'll see if it works. So when we plug in 5, negative 7 times 5 is negative 35, which is equal to negative 35, so it works. 4 on the number line is not shaded in. So let's plug in 4 to see if it'll work. Negative 7 times 4 less than or equal to negative 35. Negative 7 times 4 is negative 28, which is not less than or equal to negative 35. But if we plug in 6, which I know that arrow is going to cross over, negative 7 times 6 less than or equal to negative 35. Negative 7 times 6 is negative 42, which is less than negative 35, so it works. Why you have to flip it is because as you go further away from 0 towards the right, when you're going more positive, the numbers get bigger. But as you go further away from 0 towards the left, more negative, they get smaller. So opposite concept. It's because of where that 0 is and how the number line flips at 0. All right, I encourage you to pause the video and try b by yourself. See if you get it right. I'm going to solve for b now. So 5 is greater than negative 2/3 x. To get x by itself, I want to divide by negative 2/3. Have to divide both sides by negative 2/3. And 5 divided by negative 2/3 is just like 5 times negative 3/2, which is going to be negative 7.5. I divided by a negative number, so I need to flip the inequality, it was greater than, now it's less than, and the 2/3 cancel out, so now I just have x. And again, they're easier to read when the variable is first, so x is greater than negative 7.5. Just do a number line. Here's negative 8, here's negative 7, so negative 7.5 is in the middle. And we have a circle at 7.5. It is not shaded in because it is not equal to. It's greater than, so it points to the greater numbers. You can plug this in to check. Negative 8 will not work, negative 7 will. All right, last example for today, we have some problem solving. You have at most $3.65 to make copies. Each copy costs 25 cents. Write and solve an inequality that represents the numbers of copies you can make. So each copy costs 25 cents. I'm going to pay 0.25 per copy. I have at most $3.65, meaning whatever I spend has to be less than or equal to $3.65. So 0.25 times C is less than or equal to 3.65. Now I solve for C, I need to divide both sides by 25 cents. And C has to be less than or equal to 14.6. And I can't have 0.6 of a copy, so if we're going to rephrase this to answer the question, the most copies I can make is 14. All right, we'll wrap it up with some summary questions. What happens when you multiply or divide an inequality by a positive number? Well, we solve it the same way we would an equation, use inverse operations, gem just backwards. But what happens when you multiply or divide by a negative number? When you multiply or divide by a negative number, you have to flip the sign. That's an important part in today's notes. How would you solve the following inequality? Negative 4y is greater than or equal to 8. Well, you would divide both sides by negative 4. Because you divide by a negative, you'd have to flip the sign. So why is it important to check your answers when you solve inequalities by multiplying or dividing? Sometimes it's hard to catch those negative numbers, so when you check it, you know you did it right. It's important to check your work to check the details.